Okay, we're going to do long division of polynomials. And I'm going to compare it to a regular, um, you know, third grade division problem and show you how very similar the process is. So if you ever forget how to do this, just remember it's the same as what you've been doing your whole life. All right, so we're going to set this up to where we have x minus 2 outside of a giant bracket here, and underneath will be x squared minus x plus 4, just like a regular division problem, except this is with, polynomials versus this one. So once we get it all set up, watch what happens here. If I take 9 into 28, what I have to do is figure out how many times 9 goes into 28, which is 3 times. And then I multiply these and make this 27. I draw a line, and then, perhaps you've never really thought about this, but you actually don't add these together. You subtract them. Or you basically change the sign, right? I mean, think about it. That's what you do. You change the sign here and then add the numbers up and get 1. All right? Now, as bizarre as that sounds, I know you're thinking, well, you just subtract. But actually, what you do is you change the sign. Because it was 27 and now it's negative 27, and you add these numbers up. You have to do that on these over here. So watch this. If I divide x minus 2 into this thing, I look at the first term here, which is x, and the first term here, which is x squared, and I say, well, how many times does x go into x squared? And that's like saying, what do I multiply x by to get x squared? And that would, of course, be x. I multiply x by x to get x squared. Okay, so I'm going to take this blue x and multiply it by this thing. So I'm going to multiply these two things out. So that's basically going to be a problem that looks like this, all right, where I distribute, and that's going to be x squared minus 2x. So I'm going to go ahead and do that and put it right here, x squared minus 2x. I'm going to put my line just like I did here. I put that line right there. And now remember, what did I do over here? Well, I changed the sign. So I have to, I'll do this in like a different color, like red or something. I change these signs here. So I'm going to make that a minus, and I'm going to make this a plus. And then I'm going to add the columns up. Just like I did here. Change the sign, added them. Now I'm going to change the signs, which I already did, and add these. X squared minus x squared will be 0. And of course, negative 1x plus 2x would be 1x. 1x. Let me go back to a brighter color. And then I'll bring the 4 down. So x plus 4. Okay? So this is x plus 4. Now I have to keep going. I'll show you how to handle a remainder on that problem here in a minute. But now all I have to do is figure out what I multiplied this x by here to get this x. So what do I multiply x by to get x? Well, that's 1. So I'll put plus 1 here. And then, of course, I just take 1 times each thing. All right, so I take 1 times x minus 2, which is, of course, just x minus 2, because 1 times that's itself. So this is x minus 2. I'll draw my line. And again, going back to red, I'll change the signs. So that's going to be a minus, and this is going to become a plus. And then I'll add the columns up. So that's going to be 0. And that should always be 0. This first term here should always be 0. Every time you do it. That's how, if it's not, you did something wrong. But when you add these columns up, you get 6. So this is a remainder. All right? This is a remainder here. But let's go back to third grade here and see how we handled this. Now, I know that, the very first thing you did was write that, 3 remainder 1. But that's not how you do it later on in life. You write this as 3 and 1/9, right? 3 and 1/9 would be how you would express this answer, right? If you're converting, like usually this happens when you're converting, say, 28 over 9 into a mixed number. And that would, of course, be what you would do there. I'm sure this is ringing a bell. But you take this and put it over that to make this fraction here. So what do I do with this thing? Well, if you have a remainder and you're long dividing, this final answer would be x plus 1, that's of course this, x plus 1, with a remainder of, so you would put plus 6 over x minus 2. That's the remainder. Think about it now. Isn't that the same thing as this? Because 3 and 1/9, I mean, think about what you just said there. 3 and 1/9 is the same as 3 plus 1/9. I mean, who knew all these old fourth and third grade math stuff is so important now? But usually you just write 3 with a 1/9 right beside it. But in long division of polynomials, you got to put a little plus sign there. So that's how you would handle long division of polynomials. And this, these can get harder, but that's the basic fundamentals of it. I'll talk to you later.